Hello and welcome to the next episode from the Data Science podcast, Data Science mit Milch und Zucker. Today is the first episode that we record in English. I think we have also a wide community which is interested in data science in Germany, but they only speak English. So I think it's a good opportunity today. The quick reminder, we won't make everything, the complete podcast in English. It's just some sections and we focus still on the German market. That's why we have today Shahzad Cheema. He is lead AI expert at Huawei Technologies, and he's also working in Germany, made many projects in the German market. So here we have the connections, which we will focus also in the future while speaking English. So welcome, Shahzad. I'm glad that you're here and joining our podcast.
Thank you, Benny.
And then let's jump in. You have a wide range of projects in AI in Germany. So we will discuss about challenges, how to start successful AI projects, how to deal this. And then at the end, we will also go in how the experience this is when working with US customer, maybe differences. So let's start. What are the challenges in setting up AI projects, and what have been your challenges, and how did you solve this?
Yeah, perfect. That's a very interesting question because this is about the process of AI, and I have worked, of course, across the industries projects, and I think if I just put down in different life cycle of projects. So the first, of course, is the nature of the project. So AI sometimes has the nature which is more research oriented, like you are trying to find out, some cool algorithm for sensor for detection of gas. That's one problem. But on the other hand, sometimes it has analytical nature, sometimes algorithmic nature, sometimes it's just hypothesis. So one of the things that we have to do quite early is that what is the nature of this work. And as a data scientist, as an expert, you have to deliver that. You don't want to over engineer something when unnecessary. And similarly, you don't want to just not put the right resources or right skills if it's a complicated research project. And that also relates to the concept of ROI for the project, right? So because at the end of the day, we are working for the business, or most projects other than, let's say, typical research ones. And for a data scientist, it's good to understand that where is the ROI, how much effort we have to put, how much is the risk, and that should be, I would say, communicate very well. So typically, one of the challenge with the business is, AI is in a hype right now, especially this ChatGPT topics. Everybody wants, use, and it looks like it's working. And it's good to actually, have a out of the box idea and wild ideas, but it's also very important to understand with the business this language, the hypothesis. Okay, we should write down this statement. Okay, this is what I am expecting from the system in these certain conditions, and and this is the next level of hypothesis, and so on. So this is what I would say is also one of the typical challenges. So what I typically do is that I try to agree on a statement, simple high level statement with 80% accuracy. The system should work with 90% of the cases, or the other way around. Yeah, of course, then there are more details, on this levels of data, science, technology, people, even. So there is a lot of challenge with how to deal with with the teams. Some projects have very, very complex teams and large teams. So that's also, let's say, one dimension. Yeah.
Yeah, so let's summarize. So first part, of course, is, as I understand, we go to the business and we need ROI, we need real case, because otherwise I also have seen it. Some people, that just start, before some 5 years or 10 years ago, it was, we just spend some money and something will fall down from the sky somewhere. But I also think it's better to have some ROI, get this business, and we want concrete detail. Then you say, okay, business owner, we make this statement, we reach 80% of accuracy, or we try to reach it, and then you dive in, and then you mentioned like over engineering to avoid. Do you have some examples maybe to dive in this part to avoid this?
Yeah, sure. For the over-engineer topic, it's quite often, you have a latest method, for example, where you are, let's say you are working on an anomaly detection from the sound, right? So typically, first thing you should do is somehow analyze, the data, try to plot it the way it looks like, try to use some simple method. And I have often seen that, of course, there is research on a very complex method. Let's say you could have an autoencoder which has these Milch spectrum functions first transformed into the image, and then the image is used in a CNN, which is the state-of-the-art method, by the way. However, if it's not fitting into your problem, if your problem is really on a one level before that, if it's just a very high level, simple problem that, and maybe if the data is not enough, because sometimes you can put it into a very complex system, like in this case, and you don't have left with enough data to train such model, and you may end up actually just fitting into your data, but not any generalizable model. So we should try to stick with this Occam razor, which is that simplicity is the better, and it also explains well.
And do you see there also, like with over engineering to reusing? I heard about this trends that you can reuse existing models in the internet. Maybe this is also apart from the over engineering, that you don't develop everything by yourself.
Yeah, absolutely. I think that's also because over the time, what data scientists, because a lot of things are now open source, and that's really good what is happening right now. And we should really use as much as possible, that is out there. And maybe just that's what is research part of data science. Just keep an eye. The new models, they keep coming like every month, something really cool, and just find out what is really best and use it. This transfer learning concept, and it works pretty well so far.
And then do you have some, it's of course hard to say, but some number or how you would approach over engineering? So you say, you would approach, if you say 80%, once it's reached, you stop putting more layers or putting more tuning, or you would say, okay, I go only with one algorithm, or you make a grid search. Do you have some insights in this area, what you would recommend?
So I think typically what I try to do is that I would say we have three types of. I mean, if we just go directly on the machine learning model level, even though there are more parts, in the pipeline, how you process the data and so on. But let's say if we are just talking about the model, we could have a very simple tabular approach, set a regression model. Let's say if it's a regression forecasting problem, just look at how good it is, doing. So you came up with a baseline, right? And then you go for, let's say, something like random forest, the classical machine learning. You're in the next levels. Then you go to the neural network. What I see so often in these problems, especially forecasting, is in industrial problems, you have a little bit of data, and then a lot of time the data scientists, they want to move on to the a neural network, and then they are lost somewhere. They just hope that it works, and then I ask, maybe you could try something like a simpler thing like random forest, and it's at least you build a baseline and things are in your control. And so often it happens that for those small problems, these models, they work perfectly fine and perfectly well. So I would say it's like setting up the baseline first, and then using that baseline to build something on top.
Yeah, it's really cool structure to say, okay, I find a baseline that you are not lost. I also see data scientists, especially if they are juniors or coming from university, they start, as you mentioned, putting out encoder the fanciest model, which they train on a Kaggle competition. And then they got lost because data is not there, and they got lost and do here and here, get stressed. But as you said, if you make a baseline with a simple, then you have this one, and then you can say, I improved this 5%, go to business. Ask them, should we go on? You see the results, we are proceeding. It's a real good recommendation. Maybe also to jump to the other topic which you mentioned, then it was the right skills. Could you please also, or can we jump in a little bit on this topic?
Sure. So I think, by the way, I have an article exactly on this. What it was the data science skills, the landscape, and I divide it into four levels. Data we can leave. It's structured, non-structured, small SQL. It's good to, know SQL. It's also good to have some idea of one of the no SQL languages, at an early career. So the second part that I typically would say is really one of the languages. There was a discussion a few years ago about Python or MATLAB, but I think now we all agree on Python. Finally, it's a good one, right?
Yeah.
And then master the machine learning, deep learning. So I would say it's for early career. If you start early career, it's a good idea to do the breadth in a more breadth first style skill development. So you go for a bit of language, bit of model, a little bit about deep learning. Don't go in too much of depth. This could also happen for a lot of data scientists and that's a problem for industry to how to keep engaging someone for 5 years. But if you're really solving one problem for 5 years, I would not suggest that right from the beginning of your career. So you build more like, in a breadth first, and then you can make it T-shaped, and then you can become expert into, some price optimization, forecasting, vision problems, natural language problem, and so on. So that's what I would say is more the algorithmic side of the things, that how one can progress. From technology, as I said, it's Python, uh, I would suggest it try to be the full stack data scientist. At least try to make something. You should have at least some taste of cloud over the time, so that you can make an application end to end, or at least you have a good idea, how things work. Almost never ever it's like a model running on your machine in production. So you have to have this survey of the technology. So if I say one more thing, I think it's also about this. As a data scientist, you need to think more like a solutionist. So your job is to, build a solution. So you have a problem, you solve it. And no matter what, comes on your way, sometimes data scientists get into a bias of a certain language, a certain method, and a certain technology. And that we have to discard, because often there are not many people available to even guide the data scientists. So you can just do whatever like and run the project.
Yeah, it's cool. One remark also about the article. We will link it in the podcast. We put it there. So if you're interested, all listeners, just to click there on the link. It's the first time, so I don't know if you can just link or you have to copy, but we put it definitely there. And from the content, also it's interesting what you said about keep the data scientists engaging or to keep them motivated. Because also it's what I see in practice that because you have a project, and a data science project, normally they take much longer, like you mentioned. Maybe they take 2 years or 5 years if it's bigger topics. And yes, like you mentioned, so you should also change a lot to keep the motivation to learn something new. But on the other side, I saw also if people, or data scientists, they build a model, they run it, and then they go away and they don't do the monitoring, don't do optimizing of the model, don't track if there's a data drift. All this then is lost. So do you have an idea how to keep this, or also for the companies to keep the data scientists motivated, maybe by changing, but not to lose the track, and also if new people, then they lose maybe about the project, or they don't follow up with the monitoring with the complete life cycle. Do you have some ideas in this regard?
Yeah, sure. I think that's really very, very interesting question, because people management is one of the challenging thing, and data scientists are, a special type of unicorns, so to say. So I would say it's typically that we have to get to this responsibility, this ICAR type of structure that, people are, there is an accountable, there is a responsible person, and the data scientist. One condition that I often put the data scientist, I say a good data scientist knows the data very well. So it should be really on top of your head. That is, one of the requirements. So by the time, if it's not really on top of the head and you have just built a model and deployed and showed, let's say it's 99.x%, you're still not done. And that would mean that you have to have this precondition that you have done proper analysis. I have worked actually with businesses, and where there are really people who have been working with, let's say, 20 years on certain function, but a data scientist in a couple of years can become expert of the whole function because they see through the data. So I would say maybe 5 years is too much. But it should be that the data scientist is responsible for end-to-end product type of delivery. It's a very common problem. Many competitions like in universities are Kaggle. They focus a lot on, and they cannot do more anyhow. This model development, given the data, develop a model, show the accuracy. But we have to make sure that it gets into production and you get a reward for that. So that's what we also try to put, and that's exactly what it looks back to, this technology stack. So when I say it suggests the data scientist, it's like get familiar with one of those technologies which is production related. It could be something more on the IoT side, something more on the cloud side, but just make sure that you are deploying. If I go one step back to the skills, let's say once you have built the model, try to be good at either cloud or at edge or at hardware. These are the skills which will differentiate the data scientists from just the normal users of machine learning in their pipelines.
Yeah, it's a good point, because always all our data scientists, they learn or want just to train models, make research, but then in the end, I think maybe 60-80% or more of the time you need data preparation, then data analysis, you need the cloud tools. If you don't know these, you cannot use it, you cannot do your job. So I also think it's going to this full stack data scientist, or at least be in a team and have somebody to support you with these topics, to be a team player in this regard. Do you have some other topics or challenges during AI projects, maybe also for direction of management, or for the general completion? How we went in of the data scientist about the skills.
Yeah, sure. I think I would also refer. I have another article which I like. It's more about the 14 rules for data science, that I would write you the link.
Yep.
Because this is based more about the data scientists, how to do the practice of data science. And one of the I would say one of the principle I say is that it's be optimistic during ideation, because you want to develop something cool, great. So just think that you can do, go out of the box. Pragmatic during planning, so that you are really putting the right amount of time and resources, and critical during analysis, pessimistic during evaluation. And that's important, because so much time, the first results of a data scientist is almost 100% model, and then something has gone wrong, right? So you have to be self-critic. As a data scientist, you have to have this dichotomy in your personality, that on one hand, you are cool, you build something and you are confident, but on the other hand, you are skeptical that something is probably wrong. It looks so stupid when a data scientist presents results and he later on figure it out that, look, all the numbers were wrong. Because it's easy for the software quality, other people in software industry, things do not simply work. They do not pass those tests. But in data science, often things will work. No one will be able to give feedback. So that character of a data scientist, I think it's that I noticed that it has to be developed. It comes with experience, but it also comes with a certain openness. Yeah, that's one thing I would suggest. Another thing I would say is that, let's say, 4 eyes are better than 2 eyes. This is again related to these qualities. So that just ask people to cross check. I was working at an organization, for example, DHL, and there was a really great culture of asking and bringing other people to comment and criticize and challenge your code and approach. So that really helped, I think, to develop the skills. So also one more thing I would say, as a data scientist, learn. It's okay to learn Excel and PowerPoint. You have to express what you are doing. And don't expect so much people to just get your point. And finally, I would say, back to this full stack data scientist point, I think it's very important, because nearly a lot of AI is getting automated. So if data scientists are not moving towards application development, the application developers are definitely moving towards AI. So they will be able to use all these APIs and just get it. So I see there is only 2 types of software development. What I know more of it's like with classical, with AI and without AI, and eventually everything is moving towards AI.
Yeah, it's cool topics. Also the 4I principle. I think also to be or to talk to business if you have some results. I think if you talk to them and they know their business, then they can say if it's reasonable or not, to involve them, to communicate with them, also to get the domain knowledge if it's really realistic. Also, the API will come more and more to be there open for the new tools and the changes, not only to train the models. Do you have some, for the projects to be maybe realistic? You mentioned, do you have some advices for that to estimate the efforts for a project? Because it's also from IT projects, long time when I started, it's always the critical point that you estimate. And with data science, I feel it's not better; it's even worse to
Yeah.
make realistic estimations.
Yeah, that's a difficult topic. But over the year, what I have learned is, of course, first of all, do not overpromise. It's fine. Educate your client and discuss them with pretty openly the risks that are involved. We started, let's say, in 2016-17, the state of data science was like, 83% project fail. Right? We have, got much better now. By we, I mean as an industry. So maybe 50% projects are doing. If you're a great data scientist, maybe you're like, 75% projects are going very well. So this risk shall be communicated anyhow, so that your, client or business, they understand that part. If there is risk, sometimes there is no like easy things. So the way we do, I would go for estimation is that I divide them into three parts. First part is typically this discovery phase, and in this phase, then we go for kind of design thinking type of workshops, and this goes typically 1 to 2 weeks. It's always good. So even if you give somebody proposal, this don't make it like 6 months proposal right away. Just say, okay, 2 weeks or 4 weeks. After that, we will see. Then we go for POC, but often also the minimum viable product phase that for a typical project, it goes into the scale of months. If it's a simple app, maybe 3 months. If it's really, a large project with infrastructure and many entities, maybe a year or a couple of years to get to a product level. And then it's third part is product. So you show the client, the roadmap, the gates, the particular risks. And that's I think that's also set some hypothesis target. Okay, we should move on the gate one if this happens. So, and secondly, I think so. It's like this discovery phase, and then this planning, and then when you're delivering, then we follow this crisp model. This is crisp data mining, cross industry standard procedure, where we have this whole cycle of model development and testing and the data and domain understanding and then we combine it with an agile approach. So what I do is that then I say, look, we design our MVP in multiple sprints, and technically each sprint is one way or other way a kind of crisp, where we improve the model, add new features. This makes it easy because even if you go, beyond the limit, it's really, that you have already all the time something developed. You already always get some feedback. So the client is already always in a loop.
Yeah, I think also it's hard. I always get, anyhow, people or clients ask you, how long does it take? It's like a question you always hear. Now I don't never tell any date at all. It's like you mentioned, just to go in the loop, make a close contact with the customer, get feedback, present him what you have, decide together to move on or not. But to say it takes, let's say, 1 year, I never do this. I wouldn't risk, rather to go this approach with Crisp and get feedback loops and go together. Nice insight on this part. Maybe jump over to a different topic. You had many projects already, and also worked with companies in US. Maybe you see also differences in companies in Germany and US. Maybe you have some insights or some lessons, experiences over there.
Yeah, I think, So I think a disclaimer is like, okay, I just do not work like too much with the US, but I have good exposure to US also for Asia and Germany as being my base. In US, typically I see most, the startups and the entrepreneur, and they're fast. I think it's not nothing surprising. Germany is typically slow. The risk-taking culture I see in U.S. organization is much higher. Decision making is also quick. Um, but I think there is also a historic reason behind that. So the difference is like even in AI field, I read somewhere it's typically around 200 PhDs of AI in Germany per year, compared to 3,000 in US. So you can just see the scale which comes out of the university right away, and then of course all the large AI driven technology companies, they have they are based in US, and then we have all the Silicon Valley. So there is a huge momentum in US. Not that Germany is doing bad for its size. Yes, we have those in corporates, large corporates, things are slow. The decision making on the risk taking I observed is not too much. Projects takes like years to decide sometime. Data privacy, not a complaint, but it's again like we are data hungry AI people, so they want to do something. But here, it's one of the challenge. So there is I would say several difference inherent into the way the system is organized. On the other hand, in Germany, of course, there is also certain, you already know you're almost always compliant with the data. So that's I would say. Similarly, Germany also has I would say a bit of internationalization. Even still, it lacks internationalization compared to US, which attracts a lot of talent from all over the world, and not so in Germany.
Yeah, I think also the data privacy topic which you mentioned, I'm still wondering whether some say it's advantage economic if you say it's data privacy, but on the other side it can be also a disadvantage, like because you cannot do so much stuff as you want. On the other side, it could enable trust that people decide, okay, I want to put my data in Europe where it's safer. So I think it's two sides which needs to balance on this side. And
Exactly.
still don't know which one.
Exactly.
And
it's exactly. Not exactly. I mean, it's like if it's in US, there were states which allowed the test drives of autonomous driving quite early compared to what you could imagine, and that's what we see also in the German auto industry apparently being behind the industry there. So that would have been difficult. I mean, by the way, of course, German industry did a lot also to get to the AI. I know examples where one of the mitigation that the German industry is doing. I see two let's say major examples for the large industries. One is that making the AI as a corporate function and just getting it very close to the corporate strategy. That is what I used to be when I was in industry in the DHL. So that is really good because then you are really at a very top level, and then from there you can work much efficiently and grow the company into AI. And
yeah.
So you got a power, if you're just like close to on a lower end, maybe that's not it's difficult to grow. And the second case I see where the companies, they started making a kind of sister child software company startups, like a large automotive, which then had the ADA startup, which is completely separate. So their kind of motto is the money from the giant, but the work culture of the startup. This is also good so that they can make quick decisions.
Yeah, it's two really good points. I also saw some like heating producer. They really made their own startup, put everything out, or created completely new parts without the old, let's say, technologies, and they really succeeded. They have been really successful. I think this is also one part. And the first one, it's also so true. Often people or management, they just say, yeah, it's cool. We put AI, it's marketing, it's fashion, we do it. And they put it to the PowerPoint slides. But if they're not really behind it and they don't put it really on top, and top management is aware of AI and they're focusing on it, I think this is a really big issue in Germany, that they just say, yes, we do, but really to put it on the top level and to push it, I think there it's really, really missing still.
Yeah. And then third is, sorry, we just have also the medium and small companies. They also suffer because in the medium small companies, particularly for a new field like AI, you don't have in-house skills. And the best strategy for them is, of course, to go out and find out. And this is like where the attitude also comes, like, okay, who should we bring? I mean, it's very difficult to, get an AI expert if the company is really small and not really an AI company itself, if you're doing some other business. But you still need to change your product, adopt it to that. And that's why you have to go through to the service providers. This is also what I see a small and medium industry facing the challenge.
Yeah, the small industry is really hard to get data scientists, and if they get data scientists, it's hard to keep them. What we discussed at the beginning, to keep them motivated. If they're just alone, they have nobody to talk. No, let's say this in German, it's called sparring partner, or it's just to discuss something. Then they're often lost and have to fight alone against all the movements in the company, and then they get frustrated quite soon, and leaving is also a big challenge in that area. I think we discussed already a lot of tips for data scientists, but we can still, if you have one, we're reaching the end, to give some tips for data scientists, for beginners, maybe to summarize. We discussed already quite a lot, but anyhow, we can emphasize it at the end. So what would you give to data science beginners or project managers as advice?
Yeah, I think for the beginners, I would say I did quite some interviews for the data science positions. It's look about when you're doing job search. I think it's good to learn about the industry and the business. And even myself, when I got the job, I was like, okay, why I'm not getting a job? And then the first job where I actually really looked into what they are doing and how this is related and what are the use cases I got. So I think that's just be open up towards the job search. The second part that I said is just make your skills more the T-shaped. I would again summarize third part, which I said, yes, in that T shape, you should have something which is, unique, typically cloud, one of the very, very high skill area, or hardware, or, something about the edge or IoT. And of course, there are like 14 rules I can talk about.
Yes, many. Okay, then let's just summarize maybe up, because it's a good point with the T-shape, because I think maybe not everybody knows it. T-shape, it means that you have a lot of skills, like the T, the top on the T. It's they have a lot of skills. I think, like you mentioned, cloud, DevOps maybe, and then the T is the devs in the middle, and this is maybe some autoencoder, some AI components or TensorFlow. So one specialization with the devs and the rest not. And I think also for projects it's cool, because some project managers, they can put different T's together. Then you have a team, is everybody has a different specialization in T's, but a good knowledge to work together. I think it's a good advice for everybody to look for the T-shape skills.
Absolutely. And if I say finally, it's like it's not only the technology. I think the differentiation that would come, and data scientists will probably see it first, is that it will be this emotional intelligence and the personal, skills and communication skills that would matter a lot. And that's where they should also focus and try to, work at.
Yes, also the soft skills are quite important to communicate. Otherwise, you cannot. If you just show numbers to management, then nobody can read anything. You also have to present, communicate, get feedback, get everything. It's a very, very important topic. So, thanks, Shahzad. It was really a pleasure to meet you and get all the insights. I think all the listeners learned quite a lot to make successful projects and to be good data scientists.
Thank you very much, Rainer, for inviting me. This is really a pleasure.